Welcome back, everyone, to Hope 2020. To all of our people watching from around the world, we've had over 100 countries watching our streams so far. Welcome, welcome. And on to our next talk. There are many reasons to automate web browsing for security purposes. This talk will share basic concepts and advanced tips and tricks from years of experience automating browsers. And now the author of InfoRiley's Crafting the InfoSec Playbook, creator and host of Wall of Sheep's Lockpick Gauntlet, Forever Curious Maker and Breaker, Matthew Valites.
Thank you very much. Appreciate that intro. Hi, everybody. Matt Valites here. I want to thank the organizers of Hope for allowing me to share this presentation, and I want to thank all of you here for attending. And I'm going to be talking about how you can automate your web browser. So I live in the Bay Area. I've been in San Francisco for over a decade now. I've done a little bit of everything in information security. I started doing incident response at the CERT here at Cisco. I've also done pre-sales over at Splunk. And now I manage a research team here at Cisco in the Talos organization. And Talos provides the threat intelligence that goes into all of Cisco's security portfolio. So why me and why this talk? Well, over the last few years, I've been faced with a number of web-based problems that would be far easier solved if they could be scripted. So I needed a solution to do this, and I started with a program called Imacros that was based on a talk I saw from a man named Michael Schrenk in 2013 at DEF CON 21, and he explained how to use Imacros to do some of this browser automation. There's a ton of programs, libraries, and documentation on what we're going to chat about. What I wanted to do was pull the most relevant and useful bits from that and share my experiences and lessons learned while attempting to learn all of this with you all. Essentially, this is what I wish someone had shared with me years ago when I was starting out. There's a ton of ways that you can use browser automation. Let's talk through a couple examples to start. Here's 4 examples that I came up with that we can chat through. The first is really simple form submissions. There's forms everywhere on the internet. You use them all the time. You enter some data, you click a radio button, you maybe have a drop-down box, and then you submit it. You click a button and you submit it. Do that all the time, and there's tons of reasons why you might want to automate that, both legitimate and illegitimate. How about sniping? I think the most obvious is maybe an eBay lottery. Sniping is where you come in at the last second and put enough of a bid in to win the lottery. There's so many bots out there already if you do a quick search for sniping services. But there's also game sniping that I learned about. There's sniping for things like FIFA Ultimate Team for players, and there's a bunch of open source tools, again, to do sniping that are based on browser automation. There's also gaming games. So one of the things I found is something called OpenPPL, which is Open Poker Programming Language. So it's an open source language that is meant to play a game of Texas Hold'em. So what if you attach this to a web-based poker system and you were able to interact with the game in your browser by backing it with some sort of logic-driven bot that can make decisions based on what the web browser is showing it. And then one of the most nefarious examples I can think of is credential stuffing. So if you're sitting on a stack of credentials and you want to test those, you're going to need to grab one, log into a service, grab the next one, log into a service, grab the next one, log into a service, and do that over a bunch of services to see which credentials work at which service. So you could do that programmatically. You have a list, you just go through it and you submit it. So hopefully these kind of give you an idea of some of the ways that you could use web browser automation, but hopefully it also gives you an idea of some of the complexities that might be involved if you start actually thinking through these. So say you're the poker game, maybe you are presented with your cards in a graphical format, and you have to do some OCR to read them in there. Maybe if you're submitting forms, you're doing it on such a regular basis that your IP gets rate limited. So you need to change your IPs, or perhaps they start feeding you CAPTCHAs and now you have to start solving CAPTCHAs. So there's different complexities that happen when you start using these services and doing it in an automated way. And we're going to get to how you can solve some of those in some upcoming slides. But browser automation might not be the best way to solve these problems, right? You might be sitting there and think, okay, well, there's some other things that I might do to address these. That's totally fair. So let's take a look at some of the things, some of the other tools that you can use to solve some of these problems. Here's a number of ways that you can achieve some level of web automation without using a full web browser automation framework. Starting with something like wget and curl. These tools are ubiquitous, they're lightweight, they're available everywhere, super common, and they're a really easy way of getting data. On the other end of the spectrum, from a full commercial deployment, is something like a Burp Suite deployment. This proxy allows you, it's super powerful, allows you to do a ton of stuff, comes at, I think, cost of complexity and license cost as well. There's a number of commercial services that are available, things like Sauce Labs. These are geographically distributed, scalable services that allow you to do scraping or other types of web automation. Again, a service that you'll pay for. Then there's something like Imacros. This is similar to Burp, has a free offering, also a paid offering. This is the one I mentioned earlier that I started with. Still works, still valid, and we'll go through some examples of this in a bit. Then there's something that we'll be spending most of the time on, which is full-on browser automation using a browser automation framework. There's other examples right out of programming languages. If you've been doing web for long enough, you've probably used Perl LWP, which is the World Wide Web language library for Perl, or something like W Mechanize. And then there's a ton of Python libraries that are available that we're going to take a look at next that are really great for allowing you to interact with static and dynamic web content. So I do most of my coding in Python, so that's what I'm most familiar with. So I'll share with you some of the Python libraries that I use while I'm doing web-based programming. Beautiful Soup and Scrapey are two really great tools for extracting data. You can see an example of how easy it is to pull out the links in a web page in the sample code in the top right by just creating an object and then searching for all the ahrefs. Really easy. Scrapey is another widely used tool. It's super fast and really popular. Python requests, it's a pretty standard library. It's an HTTP library. It allows you to easily send HTTP one-to-one requests. Request.html, it's an extension of Python request. It does a number of things in addition to the request library, not the least of which is that it gives you the ability to handle JavaScript, which is super important. And that's one of the main reasons that I find I use a browser automation framework, is because I need to handle some of the dynamic client-side code that things like wget and curl just don't give me the ability to do. So let's take a look at Imacros next to see what that looks like from a web automation perspective. So what we're looking at here is the browser extension of Imacros on a vehicle information web page. So Imacros is a commercial tool. It's changed hands a couple times since I started using it. It does have free offerings in the form of web browser extensions that allow you to record your manual interactions with the web page, save those actions as a macro in a proprietary macro format, and then play that macro back at a later time to essentially automate all the things that you had manually performed. I mentioned that it's a commercial tool, the browser extension's free, it's limited, but for our purposes of automating stuff, there's a lot of things that you can do, especially if you get creative with the macros. So we can take a look at what those macros look like. So here's a view of the Imacro macro format. This is an example that begins with version definition. It has some tabs set up, and then it goes to a demo URL, inputs some text, selects a drop down, ultimately clicks on a button and submits a form after doing a number of other different things. You can see that it references different types of things. There's attributes that define names of objects. We'll get to what that means in a little bit. And then you can see content, which is things like text that it's inputting into those boxes. So this macro is a result of either manually being written, or the Imacros recorder we saw in the last slide, saving this macro as you navigate a web page manually. So now I mentioned in the last slide that if you get creative with this, you can extend the capabilities of the free offering. So you can imagine here that if some of the values of content that you're adding into a form, for instance, you want to make that variable, well, you could save a macro like this and use a placeholder value, read this macro in as a file into your script, search and replace that placeholder value with your dynamic value, write this out to a file, and save it as a macro. Now, Imacros allows you to save macros as bookmarks, and you can set your browser's default page to the bookmark, which means that if you are dynamically saving the Imacro script in the same place that your bookmark is referencing, you can somewhat get some level of automation in a dynamic way by opening your browser with the dynamic value and having it automatically go to the web page because it has the bookmark saved as its start page. It's not clean at all, but it will work. There are better ways to do it, and that's what we're going to start talking about now, and that's by using webdrivers. So what exactly is a webdriver? Well, this is how W3C defines it in their standard. What it does is gives a standardized way of using proxies, dealing with web sessions, navigating pages, managing contexts like a window or a frame, dealing with cookies, handling alerts, taking screenshots, anything that you might do in a web browser, clicking around, navigating, submitting, you can replicate it by using a WebDriver. And the way you use WebDrivers relies on browser vendors providing a driver for their browser. So perhaps you've heard of something called Gecko or Chromium. Those are Firefox's and Chrome's drivers, respectively. You can download these from vendor websites, or like in Safari's instance, it's built in and available to you on your Mac right now. You can go ahead and use it as is. What the drivers allow you to do is give you a programmatic hook into your actual browser. To control the drivers, you need a driver framework, and that's where something like Selenium comes in. So Selenium is the automation framework that I use. There's a ton of them out there. Puppeteer, Mocha, Jasmine, a quick Google search will reveal a bunch of different frameworks. I use Selenium. I use the WebDriver. I don't use any of the advanced features like Selenium Grid, which will allow you to architect a distributed and headless setup if you need that type of thing. It definitely will scale to that. For our purposes, we'll just be chatting about the WebDriver that you can run on your laptop locally. Before we do that, though, it's worth looking at some of the basics of how we're going to actually identify and interact with the objects in the web browser. And to do that, we're going to have to talk about the DOM, or the Document Object Model. Okay, so what is the DOM and why is it important? Well, it's defined as a cross-platform and language-independent API, and it represents web documents in a tree structure. So this is the browser interface between client-side code and the HTML document itself. This is what allows dynamic web pages. Much like the WebDriver was a remote interface, API interface that was platform and language neutral, these are both defined in ways to be interoperable. So the WebDrivers are meant to interact with the DOM. And the DOM is how we're going to identify the objects in the web page that we want to interact with. So let's take a look at a really simple example to see how we're going to do that. Here's some super simple HTML code. And on the right, you can see the tree representation of the code that the DOM would present the web page as. The document will always be the root node of the page, and you can see the sub elements under that. So document inside the document is an HTML element. A child of the HTML element is the head element, which has a subsequent child of title, which has a value of my document. So now that we know the blueprint of how things are laid out, we need to be able to interact with these elements. And to do that, we need to first be able to identify them. So let's take a look at ways that we can identify objects within the web page. Now that we know the blueprint of how things are laid out, we need to be able to identify objects so that we can interact with those elements. Selenium provides two classes of methods to do this. One is absolute and one is relative. If you're identifying objects in an absolute way, you're identifying them by things like ID or name, whether it's a hyperlink, CSS selectors, XPath, which is XML document path, and we're going to look at that in a bit here, tags or classes. Web documents can have multiple objects with the same attributes, so identifying can become really tricky. In general, this is the preferred order to do this, assuming that things like ID are unique in documents. There's also relative methods, so things like is an object above or below or to the left or to the right. So let's take a look at how you would identify some things using XPath. Because from a security research perspective, I have found that that is the most reliable way of identifying things based on sloppy code or code doing things that it's not necessarily intended to do. When you're looking at malicious web objects, it just seems that I had more success using XPath. Let's use this really simple bit of HTML code as an example for how we can locate objects using XPath. So a really simple login form with 4 input attributes. And let's say that we wanted to identify that first input name, username. How would we do that in XPath? So XPath is a query language for selecting nodes from an XML document. So the DOM presents the document, the web document, as an XML form. And here we can see that using XPath, you have either a relative identifier or an absolute identifier. So to identify that first input name, there's 3 different relative paths that you can specify to identify that. The first one identifies the first form element with an input child element with attribute named name and the value of username. You can also identify that same input by the second one, which says identify the first input child element of the form element with attribute named ID and the value login form. Or yet the third method, which says show me the first input element with attribute named name and the value username. All those are the same way of doing it. There is an absolute way of navigating to the path, and you can see that that specifies the full path from the HTML, from the root of the document to the object. The problem with doing this is that web pages now are so dynamic that this absolute path is almost guaranteed to break, meaning that you're not going to be able to identify the object. So doing it in the relative form when using XPath, I've had great success identifying this. Not to say that using XPath is not complicated, but it's XML based, so what do you expect? So what if we wanted to identify things maybe by their type instead of a single element? So maybe like all of the name values here, how would we do that? So here we see using XPath that we can identify all of the name objects by a simple // input. This in the WebDriver will give you an iterable object that you can further process for whatever it is that you're trying to do over all of the values that are identified in the input type. This is a bit of a silly example, but if you are trying to identify all the elements in a table or all of the links on a page, you would use a very similar method as this. So that's how we locate things, but because the web is so dynamic, Even though it's asynchronous, and because it's asynchronous, oftentimes we're going to be waiting for objects to appear on web pages, and you need to be able to deal with that. Luckily, the Selenium provides some methods of dealing with waits, and we're going to take a look at that next. There's a couple different ways of dealing with the time it takes for objects to appear on a web page to a web browser. Selenium provides three types of waits. There's implicit, which says just wait X amount of time before doing something. There's explicit, which waits for certain conditions to happen. And then there's this concept of fluent, which will wait for certain conditions, and you get to define the polling frequency that you will check for whether those conditions are satisfied. On the right, you can see some of the different types of conditions that we can check for. We can check to see if an alert is present, whether the title contains a string. We can check to see is an element visible. These are different ways that we're able to control the browser so that our execution flow happens as best we can without error. Let's take a look now how we can configure our browser in the best way for using Selenium for security research. Web browsers have a ton of configuration options. Here I pulled out some of the ones that are most useful for web automation. Generally, they fall into two categories: noise reduction or things that are useful for security research. Browsers are so noisy out of the box. Things like safe browsing, which is a Google service that provides malicious URLs that web browsers can block, it's pretty ubiquitous. So disabling things cleans up your data, it makes less requests. It's easier to look through the results of your automation if you've turned off some of these things. Extensions are another way of your web browser generating a ton of web requests, so be sure to disable those. Software updates, you're going to want to disable that. Captive portals generate automatic network requests, so anything that you can do to limit what your browser does outside of your control is going to make it easier to look through the results of your scripts. On the security research side, there's a couple things that we want to do. OCSP is a certificate revocation list, so browsers can get this list and then try and keep you secure by not serving you sites that are using revoked certificates. In our case, if we're doing security research, we might actually want to still visit those sites and trust those revoked certificates. Similarly, the untrusted certificates from a security research perspective, we might actually want to trust those untrusted certificates. So these are some options that you might want to tweak. Do not track is not really widely used. It does generate noise from a browser perspective though, so disabling that shouldn't have too much impact. And then things like predictive connections. A good example of this is if you're using Google and you are using the search, that JavaScript is making predictive requests as you type. So you might want to look at how you can disable that from a browser perspective. Now on the images on the bottom right, you can see a screenshot from the browser configuration window, which many of you may have used. It's easy to change configuration settings here. On the left is the corresponding way to do that in Selenium in the code itself. It's a really simple set preferences for the same setting. And so anything that you can do in the browser configuration window, you can also set in the code itself. So similarly, how we configure the browser for more effective automation, there are behavioral things that we can do to try and make our automation not appear as if it's automation, and we're going to talk about that next. The general way that I think about stealth is to try and look like a human and not a bot. The more bot-like you appear, the more likely you are to get website protections like CAPTCHas or Cloudflare rate limits, things like that. So you want to try and mask the fact that this activity is occurring programmatically. And here are some ways that you can do that. Introducing random delays is what humans would do as they're navigating the web. It's just natural to read something, to pause, to click, to scroll, to walk away. So you can introduce random delays in your interactions with the page. Don't move your mouse in a linear way if you are using mouse movements. Again, introduce some randomness into the path of the pointer. Similarly, if you're clicking on a button, don't always click in the center. You can get the coordinates for the size of the button and click off center. Can also use residential IPs to actually appear as if you're coming from a user-like environment. And we'll chat a bit about residential VPN options or proxy options here in a little bit. Randomize your keep lives. So this will terminate your TCP connections to reinitiate a TCP connection to the server. Similarly, randomize your request rates to the server so that you are appearing to come at a more human-like perspective rather than a predictable rate. And then lastly, vary your user agents. Sometimes just changing the user agent is enough to trick a server into serving you the content for that type of device. And you can often see in tracking response data that it will identify your device as the user agent that you are passing in here. So it's a really easy way to use one browser, one vendor browser, but to change the device that you're coming from. It doesn't work all the time, but it's a really simple way to do that. So these are easy ways that you can appear a bit more stealthy. Another thing that you might want to do when you're writing your web automation is to run in a headless environment so that you can scale what you're trying to do. And we're going to chat about that next. When you actually run a WebDriver, the browser window is going to open on your machine. You're going to see the browser window open. It's going to navigate to a web page. It's going to load it. You're going to see subsequent actions completed, like text being entered into text boxes, buttons clicked, things like that. Once you've got a functioning bot that's programmatically browsing the web, there may be no need to have a display window. And so in that case, you're going to want to run this headless. And we've got a couple of options to doing that. The first option uses native support in Selenium to pass the headless command argument to the Gecko driver. So if you actually were to run the Gecko driver on the command line outside of using a web framework and pass it the headless option, you'd achieve the same results. This launches your web browser without actually opening a GUI. And so if you're running this on a system that doesn't have a GUI, like a Linux server, this is a great way to run this headless. I have had issues where when trying to capture screenshots using the native headless option, regardless of the window setting or scrolling that I've used, I'm unable to capture the entire headshot. And in those instances, what I have done is rather than using the headless option in Selenium, I run Selenium without the headless option in a virtualized frame buffer. So XVFB has been around for a long time. This lets you run graphical windows in a non-graphical environment, and this is a great use case for it. So your mileage may vary depending on what you're trying to do, so it's worthwhile to test, but it's good to have multiple options, and both of these have worked for me in the past. So now let's take a look at another challenge that we're going to face when we're browsing the web any amount of time, and that is something called modals. What is a modal? A modal, pretty simply, is a scripted element that allows you to put one object in front of another. Some examples of this might be a login prompt on a web application asking for you to provide your credentials. Could also be a setting, say in your Facebook application permissions. That dropdown could be a modal window. Could also be an alert or a notification. Say you're in a financial application and you are timed out and they're going to log you out. That warning that they pop up could be done as a modal. On the left here, we see an example of a modal window. This is as a result of the GDPR privacy settings. You'll note that the original web page is shaded. So the focus is on the modal itself. And that means that I cannot access the web page without completing the actions within the modal. This is considered a true modal window. On the right, we see a developer tool from one of the web browsers. I believe this is Firefox. All the major web browsers have this developer tools capability within them. And this tool is extremely handy for understanding the DOM of the web page that you're navigating to. So it's a great way to understand and identify some of the objects manually when you're browsing to these web pages. And then you can use those attributes in the code to identify and interact with the elements. Let's take a look at another example of a modal. In this example, we see another pop-up. This privacy is another privacy setting. This is a result of the California privacy protections. The difference here is that this is a modeless window. So you can see that I still have focus on the main web page in the back, and I can actually navigate and scroll around that web page, even with this pop-up window in the front. Now, if I click on this window, it's a different story. Once I click on that modeless window to set my privacy choices, I'm directed to this window, which is a true modal. Again, you can see here that the focus is on the modal window and not on the background website, and I'm not able to navigate that website until I satisfy what this modal is asking me to do. Again, on the right, you can see another example of the developer tools, and in this you can see reference to the name of this pop-up having included some mention of a modal. Okay, so we know what modals are. Let's take a look at how it is that we can deal with these as we're automating our web browsing. Here are 3 ways that you can deal with modals or pop-ups in web applications. They all follow the same basic process, and that is first to determine whether this is something you see consistently every time you visit that page or whether it's intermittent. Depending on that, you have to write some tests to detect the window to see if it's present. And this is likely to use the waits that we've discussed earlier on in the presentation to wait for that object to appear or not appear. Once you're able to determine that it's present, you have to actually switch to that window to make that the active object so that you can then do something with the object. And there are a number of ways to switch to that window, as you can see on the right in the sample code. Once you've made the modal or the pop-up the primary, the active window, you need to do something with it. And again, depending on the type of modal that you are presented with, you might click on it, you might submit it, you might enter some data, you might dismiss it. So having multiple options for handling these different types of modals is super important because you are almost guaranteed to come across these if you do any amount of web crawling for a significant amount of time. So it's a great ways to handle clearing modals. Let's switch gears a little bit now and talk about proxies and the role they play within web automation. If you want to change where it appears that you're coming from, or if you want to appear to be coming from somewhere specific geolocation-wise, you're going to need a proxy. All of the tools that I've mentioned so far, Selenium is no different. They all support proxy usage. This is one tool that I've seen recommended before. It's called Luminati. They offer static residential proxies, as you can see here. They also have mobile residential proxies. So these are network locations that you can proxy through that make it appear as if you're coming from a network range reserved for mobile devices. This is a great option to have from a security research perspective. It gives you the ability to mask where you're coming from and not look like you're proxying through a data center, which is pretty easy for websites to block data center IP addresses. Cloud providers like AWS, public cloud providers, publish lists of IP addresses. So if they see web browsing coming through data centers like that, there's more of a likelihood that they're going to be blocked than if the server sees a request coming from a network range that's typically associated with end user mobile devices or residential networks. I think it's good to know if you're using the Illuminati service, how it is they get this proxy access. Their sister company, Hola VPN, provides a free VPN. If you install this VPN, you become a proxy for the people paying the Illuminati service to use their proxy services. So there's no such thing as a free VPN, and this is just yet another one of the ways that VPN providers use your connection or what you're giving them access to in return for the free VPN service.
So let's take a look at another thing that we're going to come across all the time if we're web browsing, and that is CAPTCHAs. So what's a CAPTCHA? It's a completely automated public Turing test to tell computers and humans apart. The whole point of these is to detect bots, just like the ones that we're talking about writing here. There's tons of different types. reCAPTCHA, in my experience, is one of the most frequent that I come across, but there's a whole bunch of JavaScript types now, a whole bunch of commercial services that provide these capture services. So we need a way to get past these, and luckily there's some really inexpensive and nice services that will solve these for us. There's a number of capture solving services out there. This one is called Anti-Capture. They're not very hard to find. If you use this, you sign up for the service and they provide you an API key. That API key allows you to upload any captchas that you encounter to their service, which they assign to workers to solve. The cost for a reCAPTCHA is anywhere between $1.80 and $2.20 per 1,000, so pretty economically viable. This service can also solve some of the JavaScript CAPTCHA challenges that we saw previously. Let's take a look at how it works. Here's the process for a reCAPTCHA. The way it works is your web automation will access a web page and be served a CAPTCHA. That CAPTCHA has a site key, which you grab and provide to the CAPTCHA solving service. It's a unique key. That CAPTCHA solving service then gives that job to a number of workers who solve that, and they compare results, and if the majority of results are the same, they give you back that response. Something like a reCAPTCHA on average is about 30 seconds to solve, so pretty quick. You take that now that it's in your application, you serve that back to the website in the form of the CAPTCHA that you were served, and it solves the CAPTCHA for you. Other CAPTCHAs, like the simple images, you can take a base 64 hash of that image and supply that to the CAPTCHA service, and that's enough for them to solve those. So all the CAPTCHAs are basically using the same trick, where you identify the unique attribute of the CAPTCHA solving service that they can access and solve and provide you with the answer that you can then submit into the form. And it works quite well. This CAPTCHA solving service also provides a browser extension. This browser extension is smart enough to automatically detect most of the captures, extract the site key that we talked about, send that to their service to solve, and then receive and populate the response to solve the captcha for you. If it can't do it automatically, you have the option to identify it by right-clicking on it. You can identify the captcha and then the input field, and it'll learn that the next time it gets the same captcha. Both of these methods are really reliable ways of getting past most captchas that you might encounter, and doing so at a relatively inexpensive way.
And we're back with Matthew Valites. This was a great presentation. Thank you very much for preparing it for us.
Thanks, Jen.
Now, so we do have a couple of questions from the chat. First question that we have is what your thoughts are on tools like Fiddler and Insomnia and similar tools.
Yeah, so I've not used Insomnia. I'm aware of Fiddler. I've not used it. My understanding is Fiddler's a proxy, so you can do things that you can do with other proxies, right? So like Burp Suite, you can see the requests, you can stop them, you can change them, you can replay them. But things like accessing the DOM, accessing client-side code that would be running in the browser, that is not possible with the proxy sort of stuff. So probably similar use cases, something like Burp Suite. And like I said, Insomnia, I'm not sure, I'm not familiar with.
Okay. And in the chat, we've also had some folks talking about Gopher and Project Gemini to go a little bit back in the day. Are those a good starting point in your opinion?
I mean, I've not. So when I saw those chats, it really took me back to like 1990, hearing about Gopher. I think the modern web, again, so could they be useful? Absolutely. I think if you're getting to things where you're doing client-side scripting and you're dealing with, JavaScript and stuff like that, something like a WebDriver is probably going to be a lot more useful for you to interact with the browser. But again, old school tech, haven't used it in a long, long time. So probably good for historic purposes, but I'm not sure for automating the web.
Now, how detectable are these techniques? If you were trying to protect yourself, what approach would you take?
Yeah, so it depends on how programmatic you appear, how frequently you're making requests, where you're making requests from, right? There's a whole bunch of different attributes and factors that are going to make yourself more detectable than not detectable. I mentioned using proxies to vary where you're coming from, making your interactions with the website look as human as possible and not as bot as possible is going to help. But I think you're still probably at some point going to face things like Cloudflare pages, CAPTCHAs and stuff like that, which is why you've got to be able to deal with those if and when you do get them. And if you're using this for security research purposes, I'd like to think that sometimes the attacker's infrastructure is a little less robust than, say, Fortune 50. And so hopefully, or maybe you'll have a little bit more success getting past some of the protections and stuff, but still got to be cognizant of how you're doing it. And so again, the biggest thing I try to keep in my mind is look like a human, not like a bot.
Of course. Now, speaking of those anti-CAPTCHA services, do you know where, or do you have any idea how they get their solves from? Do you think that they are offloading to cheap labor, to other kinds of mechanical turking, to machine learning, perhaps?
Yeah,
or is that just a secret sauce?
I don't know. If most of the sites advertise that they employ people, and that they actually advertise that as if it's a selling point that you're providing employment for people solving. It seems like a bit of a reach to me, but it does. I wouldn't be surprised if they were actually having people solve these, and then when they get the responses back, they compare to see if multiple people answered it. But whatever they're using, it's fast and it works pretty well, and it's pretty efficient.
And what are your thoughts? Again, this is a question from the chat. What are your thoughts on using Selenium for XSS testing?
I mean, why not, right? I don't know if it's the best use of it, but yeah, certainly that seems like a pretty lightweight way of testing sites. Seems like an easy approach, an easy problem to use this for.
You mentioned the VPNs thing. Of course, in the past couple of weeks, we've had those revelations with the free VPNs and their open buckets full of data. In your experience, do you think there are any VPNs that would be reliable, or would you just or would you shy from that?
Again, if what you need is that sort of connectivity and you don't necessarily care, again, the example that I gave was Hola and Illuminati. If you don't necessarily care about someone inspecting what it is that you're browsing to, maybe not a big deal. So what is your threat model, I guess, in what you're trying to accomplish? But the question about is there any good VPN? I think unless you roll your own, there's just no way to know. And so err on the side of caution is probably a good move.
You've also talked about using old school tools. Are there reasons to use older browsers in the research?
Sure, why not? Sometimes in some of the tests that I've done, part of what I'm trying to do is understand what do I get served content-wise based on how it appears that I'm accessing the site. So by a different browser, for instance. So varying the browser, varying the user agent, perhaps in some cases is a super simple way to trick it. There's a lot of value in that. Some of the malware campaigns that we've tracked, some of the malvertising campaigns that we've tracked are serving malicious Flash players, DMG files, and they're just malware of varying different types. But it would only hit if you were coming from a Safari browser, and that you could trick just by setting the user agent. So certainly I could see why, especially if you're testing and QAing things, maybe not a security research perspective, yeah, you might have to test coming from an older browser. So certainly, although I will say, if you're using an older browser, I don't know if you'll have a WebDriver available to you to automate it. So that might be, one of the gotchas.
Now, another question that came up was about these, again, back to the CAPTCHA services. Mm-hmm. Do you think paying a CAPTCHA solver would be in simply streamlining browsing? I can't say the word right. Simply streamlining browsing, and does sending the CAPTCHA to a third-party service leak what web page you're looking at?
So when you send the site key, it doesn't there's nothing associated with that site key that tells you what page you got it from. So there should be nothing that leaks there. In terms of, there's obviously an ethical issue here and like a EULA issue and all these sorts of things that you have to analyze and figure out how it fits within your situation. But from a data leakage perspective, you should be good there. I will say on some of the newer JavaScript ones, I don't know about that. That's a great question. I don't know if you would be leaking some of the information on where you're coming from or where that captcha was served to.
Okay. Does HTML5 provide any advantages, disadvantages, or opportunities?
To be honest, I don't know. I really don't know. I'm not a web person. This is, part of the reason that I gave this talk was because I don't have a web background. And so I had to struggle to learn all this stuff. So I thought if there were other folks kind of doing the same thing that don't have necessarily a web background or web coding background, that this would be useful. But I honestly don't know. I don't know if HTML5 would be good or bad from this perspective.
Okay. I'm just looking, and I think that covers the questions that I've seen in the chat.